Hello, and welcome to Monitoring Performance. My name is Steve Hamilton. If you have any questions or comments, please feel free to use the question and comment box found below. Okay, let's get started. In this module, we will take a look at overall instance performance. As a practicing DBA, one of the key things that you're going to be responsible for would be overall database as well as instance performance. There's really two things. One is backup and recovery. The other one is instance performance. The performance is going to be done on a day-to-day basis. Your end users are going to come to you and say the system is running slow. Please improve performance. Never will your end users come to you and say the system is running too fast. It will always be the system is running slow. What can you do to improve performance? We will take a look at how we can monitor performance and ultimately help improve performance. We'll also take a look at overall concurrency. When we talk about concurrency, what we're meaning here is the guarantee that the end user who is reading the data is only reading committed data, or they're reading the data that they need to be reading. Sometimes you can set up your systems not to read committed data, but you could actually read uncommitted data. And there might be some reasons for this, but we will talk about concurrency. The other tool that we'll look at would be DAC. And DAC is the utility that you would access in the event that nothing else is available. SSMS is down, nothing is available within your system, so you now need to access your SQL Server database through the DAC tool. So what we will want to do is to develop a plan to monitor performance. And this is going to be very critical because we need to identify specifically what is important within our own organizational needs to monitor performance. Now, we've already talked about performance can be monitored at many different levels. It can be monitored at the instance as well as the operating system. What we're looking at here, specifically when we talk about monitoring performance, is looking at performance as it pertains to the SQL Server instance. Because you are a DBA. So the things that you will have control over will be instance performance. In the last module, we talked about monitoring performance at the operating system as well as the database level. Well, if you're the DBA, you may not have a lot of control as far as performance at the operating system level. You might be able to communicate to your Windows administrator that the system is running slow, and then they could add more memory or add more CPUs. But at the instance level and at the database level, those are the areas that you are responsible for. As a practicing DBA, I will tell you 95% of my performance-related issues deal at the application level. Whether it's poorly written code or the addition of an index, the number one line of defense when we talk about performance monitoring and improving performance is at the application level. I cannot tell you the number of queries that I've improved by strictly adding an index. I have literally had queries that have run for 48 to 72 hours, and then adding an index, now they take 20 minutes. So when we talk about a performance monitoring plan, application should probably be the number one item when you monitor performance, because you will get the biggest bang for your buck by performance tuning from the application. I define this into two categories. One is called gross tuning, the other one is called fine tuning. The gross tuning is going to be done at the application. This is where you get your biggest bang for your buck. The fine tuning will be tuning specific instance parameters and database parameters. Here you might get 5 to 10% improvement on your environment. At the application level, you could get 50, 100% improvement. Now we'll look at different tools that are used to monitor different components. However, probably the biggest tool that we're going to look at would be DTA as well as Performance Studio. We also have additional tools out there that can monitor the application. We've already taken a close look at System Monitor. System Monitor can be used to monitor the instance as well as the overall operating system. We can use System Monitor to monitor the database as well. However, the system monitoring tool is predominantly a system or a monitoring tool that is going to monitor the overall system. What you want to look for as the DBA would be specifically what is going on with your environment. Now here we see the tool called SQL Profiler. SQL Profiler can be used to monitor specific transactions. Now this right here is the biggest bang for your buck, because what you're after is a DBA, and what you have control over is the transactions within your system. So we want to use SQL Profiler to help monitor the transactions, and it will tell us specifically what is going on in the system. Probably the second tool, or maybe even the number one tool that you will utilize within your monitoring environment, would be DTA. DTA is Database Tuning Advisor. Now the difference between DTA and SQL Profiler is SQL Profiler just tells you this is what's going on in the system, and this is how this SQL statement is being utilized. DTA, the key here is advisor. It will take that SQL statement, look at it, and provide you advice. Do I need to add additional index? Do I need to rewrite the query? What do I specifically need to do to improve performance within the SQL statement? SQL Profile tells you what's going on. DTA tells you how to fix it. DTA can monitor the database. It can also monitor the transactions. So my suggestion here is to use DTA to monitor both databases as well as overall transactions. When we come into the DTA tool, we have the option, this is actually SQL Profiler. When we come into SQL Profiler, we can select specifically what we want to monitor, as well as we want to monitor the database, and then these are all of the objects within that database that we're going to track. We can save this information to the tuning log. If we look at the tuning options, we can see the tuning options here. It will come back and say we will monitor the system. This is actually the Database Engine Tuning Advisor. It is going to monitor the system, and it's going to look at performance enhancements. We can look at indexes and index views. We can look at indexes only. Within SQL Server, we have what's called a PDS. PDS stands for Physical Design Structure. Within the PDS, it will ask us, do we want to make recommendations on the existing PDS, or do we want to make recommendations on a brand new PDS? My personal preference is to get recommendations on a brand new PDS. For my personal reasons is that sometimes when you do performance tuning, and if you keep the existing physical design, you're not looking at everything that's available to you. So now if we do not keep the PDS, it's going to give us a completely different evaluation process. However, it could take a little bit longer. Also, we have the option of clustered as well as non-clustered indexes. We can tell it to include partitioning or not include partitioning. So the bottom line here is that when we go in through DTA, we can select our databases, we can select specific tables within that database, and then it will provide us analysis on indexes, index views, partitioning, as well as the physical design structure, as far as what we need to do to improve performance within this database. Database Engine Tuning Advisor will give us advice on one or multiple databases, as well as one or multiple tables within that database. Again, this is something that you're going to want to run throughout the course of the day. You don't want to run DTA at 2 a.m. on a Sunday. Nobody is doing anything at 2 a.m. on a Sunday. You will want to run this at 1 o'clock in the afternoon on a Monday. When you run it at 1 o'clock in the afternoon on a Monday, you get specific information as far as those people that are accessing the system. Will this affect performance? Slightly, but it will not affect performance significantly enough. For example, if you run a backup at 1 o'clock on a Tuesday, that will definitely affect performance and it will be noticeable. Here, it'll affect performance, but it is not going to be that noticeable. We can also gather information regarding the specific instance as well as specific tables in a given database. So DTA, the key thing within DTA is it provides us advice, specifically what you need to change for the specific object. SQL Profiler is just an information gathering tool. It will provide us information or gather information about specific SQL statements, as well as general performance statistics and some limited instance statistics. Now this is a good tool, but it does not necessarily give us advice. But as a practicing DBA, we can look at this and say, wow, this is what's going on in the system. This is some of the things that I need to do to increase, to improve performance. For example, maybe I need to add more memory. Maybe I need to configure it a slightly different way. Maybe I need to change this instance parameter. I can see that CPU utilization is awfully high, so maybe I need to communicate to my Windows administrator to have them adjust CPU, or maybe add more CPUs, or whatever we need to do. So SQL Performance, or SQL Profiler, gives them specific information at a SQL level, a database level, and at an instance level, but it just tells me what's going on. So what will happen is this is available through the SSMS tool. I believe that you go under Tools, and under Tools it says SQL Profiler. When you go under SQL Profiler, you'll give it the event name. You can save this information to a file or to a table. Again, my recommendation is when you're using SQL Profiler is to save it to a specific file, because if you save it to a file, you can always recall it at a later point in time. If you save it to a file, you can send that file off to other people, and then they can review the file as well. In this particular case, that's exactly what we've done, is we're going to save this trace information to a file. The file is a .trc file and can be reside anywhere on your operating system. It is my recommendation to store this information at the file level. So now we will go into events. And we have all of these events, what we want to trace. We can show all events if we want. Now there's a ton of events that are involved. One of them that we will typically track is the T-SQL. That is the transaction SQL, and we can track everything for that specific T-SQL. You will cherry pick which one of these that you want to track or which one of them you don't want to track. You can look at column filters as well as organize the columns. Probably the best practice is to come in here and look at all of the events, and then select which event is important to you. I personally choose things like sessions as well as T-SQL. The audit log in and log out, I don't particularly track. Once you've selected this, you will hit run, and this is immediately going to start the run process to track all of these things that you have selected. You can also add a filter, so you can include or exclude certain objects, or include or exclude certain users. Here we can include or exclude certain hosts. We can look at the duration, so anything that is a duration of greater than a particular value, we will track. We can look at the client process ID, the database ID, the database name. There's about 20 or 30 options here that we can filter. So effectively what's happening is that we are creating a where clause. It says only track this information for this specific database. Only track this information if the duration is in excess of 1 hour or in excess of 30 minutes. We can also organize columns, and when we talk about organizing columns, this is just how they're being displayed within SQL Profiler. We can select event class, text data, login name, CPU, those type of things. So if we want to see specific columns within a SQL Profiler, we'll go into Organize Columns and select the specific columns that we want to see. Now I can see that I've started the trace event. And in this trace event, what I'm doing is I'm monitoring specific network protocols. I can see it's going against the reporting server for the specific for the operating system user system. We can also see that the trace is currently running. Now, if I'm done with this trace, there's a little button at the very top portion of the screen that I could hit stop, and it will stop recording the trace information. This information will then be written to a file, and then I can come back and I can review that file at a later point in time. I can even overlay that or compare that file that I ran a week ago to a process that I'm currently running. So I can get an idea as far as what happened a week ago versus what is currently happening. We have this utility which is called DAC. DAC is the Dedicated Administrator Connection. Now the reason that you would use DAC is if everything else is not available. For some reason the system is down, nothing is available. What we need to do is log in through DAC. And this is where we're going to need to analyze performance where our other options are not going to be available. For some reason, SSMS is down. We can't get into the system any other way. So DAC is a means of last resort. Sometimes the instance may not be available to accept incoming connections. Now this could happen because maybe your transaction log files are full. Maybe you ran out of space. For whatever reason, I will tell you this. If your instance is not available and you have to access DAC, you have a significant problem on your hands. Probably some form of disk failure, or the disk is full. So if you're logging into DAC, you really need to determine specifically why you are required to log into DAC. Again, like I said, typically that is going to be some sort of media failure if you have to log into DAC. DAC is going to be used as your last resort. This is the very last thing that you want to do to log onto your system. It's not necessarily going to cause harm to your system. Effectively, what it means, though, is that harm has already been caused to your system. Therefore, the only way to access my system is through the DAC tool. The DAC tool is a member of the sysadmin fixed server role. When we talk about the sysadmin fixed server role, basically when I log in through DAC, this is the same way as logging in through SA. He has the same capabilities to do anything that SA would do. So sysadmin can come in and basically do anything within your organization. The way that you use DAC is use the SQL command to access the database engine. So what you'll do is you'll go into the actual prompt and you'll type in SQL command, and now you're going to be able to access your environment through DAC. You're not going to be using any GUI. This is a very, very rudimentary command line utility. There's not going to be any drag and drop, right mouse click properties. Here you're actually going to be writing your queries through the DAC tool, through the SQL command prompt. We can use transact SQL statements to gather query information, to query performance views and gather information. So you're actually going to be using things like the DMVs, dynamic management views, to determine specifically what is going on within your organization. This is where it's very useful to know the contents of the DMVs. So have a good understanding as far as what the DMVs contain. Because in the event of an overall system outage and you have to log in through DAC, the DMVs are going to be your best friend. So for example, all objects, system users, all files, those are dynamic management views that you can query to determine specifically what is available or what is not available within your system. What we've done here is gone into the command prompt, typed in SQL command, and now I have logged into the DAC utility. Again, there is no GUI, there is no drag and drop. This is a straight up command line utility. You can come in here, you can write your SQL statement, you can write your T-SQL statement, and that's all you get. Now, in 2008, we have a new feature which is called Performance Studio. Performance Studio provides an overall dashboard of the database. It's at a glance look at the overall performance of your system. Basically, to set up the Performance Studio, what we will do is that we create a little database in and of itself. This database in and of itself is called a management data warehouse. We would go under management options. We would say configure data warehouse, or to configure data management warehouse, and it will walk us through a wizard. All this does is it creates a little repository, if you will, that will contain the information that we're going to monitor. After we've set up that particular database, the next thing we'll do is have it go out and collect information. And it will collect information for us on CPU utilization, network utilization, memory utilization. And we can choose what database that we want it to collect that information for. It could be one database or it could be all databases within that SQL Server instance. This is a nice feature in 2008. The huge advantage of Performance Studio is this information is stored in a repository. So because this information is stored in a repository, then we can come back and we can review it at any point in time in the future. So I can say, okay, a week ago, what was the performance statistics on this particular database? And I can do that. Or I can come in and say, what are the performance statistics today? Or maybe compare the performance statistics today versus how the system was running a week ago. Do you have any questions? If you have any questions, please feel free to use the question and comment box found below. Thanks for joining us.